So we want to look at how to solve basic proportions and why does cross multiplication work. So let's start at looking at some basic proportions, and then we'll go into different strategies on how to solve them and why cross multiplication is one of those strategies and why it works. So a basic proportion, x over 3 is equal to, 15 over 4. So how would we set about solving this? It's just an equation, and there's a value of x that would make this true. So some number divided by 3 is going to be equal to 15 divided by 4. And the oldest strategy out there is to just figure out what the right-hand side is as a decimal, or try to comprehend this right-hand side number in greater detail. So this is just under 4 wholes, right? 15 divided by 4 is 3 3/4, or 3.75. So what divided by 3 would get us 3.75? And you could guess and check. That's probably the oldest strategy out there, to guess and check. But we want to use algebra. Guessing and checking has its place in time, but let's use an algebraic strategy. So one way we learned how to bust fractions was to multiply everything in an equation by the lowest common denominator of those fractions. So let's do that to this problem here. So if we were to multiply everything in this by 12, because 12 is the lowest common denominator for 3 and 4, when I do the 12 times x over 3, the 12 cancels and so does the 3, but there's 4 3's in 12, so I end up with 4x. But when I do 12 times, so that was my 12 times x over 3, when I distribute to go 12 times 15 over 4, the 12's cancel, or the 12 and the 4 cancels, and I get 3 up here, because there's 3 4's in 12. And so that equals 45. So now I have 45. So now 4x equals 45, that's pretty easy. Now I just divide both sides by 4, and x equals whatever 45 divided by 4 is, right? And so that would be 11, I think. So if we actually wanted to convert that, we could say, we could do the actual division, and we would get 11 and 1/4. So x must be 11.25, or 11 and 1/4. And what we did is we fraction busted to solve this proportion. Let's solve the exact same proportion using a different strategy. So another way to maybe solve this proportion will be to just multiply everything by 3, because 3 is the denominator of the x term. So when I distribute it to this term, 3 times x over 3, I just get x, because the 3's cancel. But I still have to go 3 times 15 over 4. And so 3 times 15 over 4 results in 45 over 4, which was exactly the answer we had in the last one. So 45 over 4, again, that division, when we did it, was 11 and 1/4. So again, x is equaling 11 and 1/4. This was a bit easier in some ways because I was able kind of to skip right to that division problem. So I just basically fraction busted the fraction under the x, and it resulted in the exact same answer. Let's look at one more strategy. So the last way we want to look at solving a proportion would just be using cross multiplication. And cross multiplication, it's one of those strategies that's probably used the most and taught the most, but unfortunately sometimes kids or students are tempted to use it without understanding why it works. And that's what we want to avoid, right? We don't want to use something or a trick and have no idea why it's working, because that doesn't help us learn anything. It just helps us become robots and repeat things we were taught. So in an effort to avoid that, let's discuss why cross multiplication works. Before we do it, let's define what it is. Well, it's a process where we can say, okay, I know that 3 times 15 is going to be equal to 4 times x. And so people will do those products and set them to either side of the equal sign. So 4 times x, 4x, must therefore be equal to 3 times 15. Okay, so 4x then is equal to 45, and dividing both sides by 4, I end up again with x is equal to 11 and 1/4. But to figure out why this works, let's try a pattern approach. Math is full of patterns, right? And patterns help us identify rules, I guess, that we can apply to problems that may not be so obvious. So if we looked at something fairly obvious, like 1/2 is definitely equal to 2/4, and 2/3 is definitely equal to 4/6. If we just look at this set of equivalent fractions, the first thing we have to realize is that this proportion right here is a set of equivalent fractions. I mean, x over 3, we're saying is equal to 15 over 4. We just don't know what x is. And we need to find the value of x that makes this number divided by 3 the same thing as 15 divided by 4. And as it turns out, 11 1/4 divided by 3 is the same thing as 15 divided by 4. So let's look at the pattern with these easier fractions up here. Remember, one of my favorite strategies when I'm trying to figure something out is to do a similar problem with easier numbers. So what's 1 times 4? Well, that's 4. And what's 2 times 2? Well, that's 4 as well. Take a look at this pattern. What's 3 times 4? Well, that's 12. And 2 times 6 is 12. So this pattern emerges, and we get a set of equivalent numbers by doing cross multiplication, and it has to do with the fact that we're setting up equal fractions. So we're saying 1/2 is equal to 2/4. So by default, cross multiplication therefore has to work, because the numerator times the denominator of the other fraction should end up being the exact same thing as the numerator times the other denominator, because they're the same fractions written in different form. So hopefully I'm not overcomplicating this. So if we just continue this pattern that we see, we know the denominator of 1 times the numerator of the other should equal the same thing as the numerator of 1 times the other denominator. So 3 times 15 must, according to this pattern, should also equal 4 times x. And that's kind of why cross multiplication works, and that's how you might discover the process for yourself. So I wanted to leave you with some additional practice. So there's 4 problems here. They're just basic proportions. Use any strategy you want. I encourage you to try cross multiplication. Go ahead and hit pause and try these. And here in a few seconds, I'm going to show you the answers in my work using the cross multiplication strategy to solve these. And so here's just my work and for each problem. And just know that the whole numbers that I got in each step, so for example, this 20 right here, I just got that by going 4 times 5. I used cross multiplication for all of these, and I got 7x from 7 times x. And similarly with the rest of the problems. I hope this was helpful.